Biblical creation makes certain assertions. One is that God created the universe ex nihilo, that's out of nothing, and formed life on the earth supernaturally less than 7,000 years ago. Two, God established the laws of science, but interacts with the universe through miracles. In other words, he occasionally intervenes for whatever his purposes are and violates the laws. But normally the universe runs according to these laws that he's established from the beginning. For instance, on the sun, we have nuclear fission. Well, it was taking place before man ever discovered it. Did it start the day we discovered nuclear fission? No. It's always done that. Do we have someone that's up there tuning the sun to make sure, well, it doesn't get too hot today, and you got, oh, the temperature's getting a little high, we got to get it low? Even your own bodies have a million functions, autocorrelation functions, that determine what your temperature is, when you need water, what you're going to do, and you can walk along carefree, not even thinking about any of those things. Because why? God set the things in order so that they operate without you even having to think about them. 3, God judges the universe because of man's sin in the past in 3 events. The curse at the beginning with Adam and Eve, which affected the whole universe. 2, with a worldwide flood that we'll see later in the flood of Noah, changing the whole face of the earth and eliminating everything that lived on land during that period of time. 3rd, there was a division of mankind into languages and races. We didn't evolve by different races. We devolved from one race into many. And also our languages are not a product of evolutionary process. They were more complex at the beginning and they're degrading. 4, God will destroy the present heavens and earth and establish another eternal heavens and earth that will be without sin or corruption or decay. It'll never grow old. Lastly, God gives eternal life to believers in Jesus Christ, who is also the only one that's walked the earth that was perfect, who is the only one that's ever been a creator. Let's take academia's assertions. That's the naturalism. And that their assertion is that naturalism is science. The cosmos is all that is, or ever was, or will ever be. This is a classic statement from Carl Sagan. He's now dead, but he was a Harvard professor when I was in school. He's a pop science guru for the science series Cosmos, and you'll occasionally see that. And he sums it up. He sums up naturalism. What you see is what you got. That's all there'll ever be. And if you can't touch, feel it, or hear it, or taste it, it doesn't exist. There's nothing outside of the matter and energy that you experience and interact with. Naturalism, it's the basis of public education and court decisions. Naturalism, by definition, is the mode of thought, religious, moral, or philosophical, glorifying nature and excluding any supernatural or spiritual elements. It doesn't allow for anything but matter and energy and things you can touch. Our public educational system teaches fraudulently that naturalism, the exclusion of any supernaturalism, that's such as God or creation, angels, heaven or hell, and only naturalism is scientific truth. It's fundamental to naturalism that there are no scientific proofs of the supernatural, such as God, creation, heaven, and hell. By the way, that is a correct deal. There's no experiment that you can do at the present time to prove God or angels or anything else. That is a correct deal. But the extension of it is we're going to see that there's no supernaturalism is totally false from the laws of science. The thing that they claim that they have an exclusive on. Academia indoctrinates its students, and this is worldwide, with naturalism is science, supernaturalism is religion, and there's no intermediate ground. The products of this public educational indoctrination are law students, lawyers, judges, we should add politicians, who legally protect the indoctrination process with the judicial system. Judges use the guise of separation of church and state to enforce this by their legal decisions. They say, in the court cases they said here, if it's supernatural, it's got to be religion. If it's naturalism, which is basically atheism, then it's science. But of course, I've listened to these judges that have rendered some of these decisions. Hardly any of them know anything about science. They're solely products of their educational system. They've been indoctrinated this all of their lives. Naturalism, the exclusion of supernaturalism, such as God, creation, angels, heaven, hell, is in reality atheism, by definition. The mandating of naturalism is in our school systems and our courts is the establishment of atheism by the Supreme Court as the state religion. Anything else you can't teach by their decrees. Let's look at the two basic laws of science and get into their implications. The natural universe has only two components, matter and energy. Matter is the substance of the universe, and energy has no mass effects or anything, and it's the thing that holds matter together and gives it energy to move and interact. You can, as we saw, as you drop the temperature down to absolute zero, matter becomes motionless. There is no free energy at absolute zero. And as you come up, then the energy starts going back and forth between matter, electromagnetic radiation, or bumping each other, and things like that. So there's only two things that compose the material universe that we look at. The two most basic laws of science define every interaction of matter and energy. One's the quality law, it's conservation of matter and energy. And the second law, that in every interaction, there's increasing entropy or disorder of matter and energy. I think I told you about when I was a student at MIT, I'd come out of the time that our government was very much panicked about after Sputnik. The Russians put Sputnik in order, and our government became very concerned, and everyone else, because if they could put satellites in orbit over us, they could drop bombs on us. It was the beginning of the ICBMs, intercontinental ballistic missiles. And everyone started building bomb shelters in their backyards, in public buildings. They started storing up food. They're building systems that would survive a nuclear blast. And the government also tested everyone in the United States to find out who were the best students. And they supplied free government programs, summer camps, that you could go to if you passed high on these exams. I was one of the fortunate ones. And we had full professors pushing us in math and science to push this level up so we could catch up in what became known as the space race. In that process, I learned physics very well. In fact, I think at that point in time in mathematics, we reached an apex of students that could deal the best in math that was probably ever developed in the world. We had the highest scores on an absolute basis probably for all time. They don't even teach, for instance, at MIT in the doctoral programs what we had as undergraduates. But I went into, as a student, I went there and I knew that physics was the heart of science because, biology, what is it? It's a subdivision of chemistry. It's just an exchange of electrons. It doesn't change the nucleus. But in physics, you include not only the exchange of electrons like in chemistry, but it affects the nucleus. And these laws of science, so I was learning them. I knew mechanics, I knew wave theory, I knew optics, I knew field theories, gravitation, electromagnetism, etc. And I could run like a rat through the maze. And it was very, very complicated, and only bright people could do this type of thing. I wasn't the brightest. There were guys, I was about average at MIT. But I got there and I knew physics was the main powerhouse of science. And I lived in a small group of guys. There were only maybe 35 guys. They were some of the brightest in the world. There were 2 Rhodes Scholars in our house. And one of them got a hold of me and he says, "Dave, you're having trouble with your physics." Can I help you? And I said, yeah, let me do this. So we had big files of the previous exams, and we'd go through those, working those problems and trying to prepare for exams. And I've been through that stuff. So he slaps these problems down, and I start to write my little formulas, and he says, I know what your problem is. I said, what? I said, I'm studying hard on this stuff. He says, you got to realize that the physical world is only made out of two things, matter and energy. And he says, there's only two laws that govern this, and all your laws of science come out of these two laws. And he says, the first law is the conservation law of matter and energy. In every interaction, you have the same amount before and afterwards. I said, so? And then he says, well, take the law of perfect gas law. He says, if you take the same amount of energy, crush it in half the distance, what's going to happen? I said, well, the pressure will go up and the temperature will go up. And he says, compared to what? And he says, I said, an absolute vacuum on pressure. I said, temperature, he says, absolute zero. And he said, so when you crush it in half, you've got the same deal. So what's going to happen to your pressure? It's going to double and your temperature will double. He says, you have your ideal gas law, PV, pressure times the volume, which in half the pressure will double. And on the other side of the equation, the temperature will become double too. And he says, you have PV equals nRT. It's very easy. He says, all of your laws of science, most of your laws of science are conservation laws. Your field theories. And he started to work on gravity, showing me how you obtain potentials, but you're only changing energy levels. And he says, don't think of forces anymore. Only matter and energy. Forces is just a convention. And he says, they teach all these courses on forces and you can't do it. He says, take gasoline, you put it in a car, chemical energy. You put it in the engine and it turns to heat energy. And in the piston, it turns that heat energy into mechanical energy. You can put on the other end a pulley and run an alternator. That'll convert from mechanical energy into electrical energy. You can send that over to the battery and it turn from electrical to chemical. Then it comes out, you want to start your car, it comes out from chemical to electrical again, goes into your starter, turns to mechanical, and you can start your car. Now he says, how do you take care of that problem with forces? He says, it's impossible. But with energy, it becomes easy. You can solve impossible problems. And at the core of the Apollo project that I was fortunate to work in, I didn't do the main equations, my roommate did. Those were all built off of conservation of energy and matter. They're big, high-powered equations, differential and calculus equations called Hamiltonians, and you could solve the course that this thing would go up, optimize it, and minimize the amount of fuel. Didn't use forces, you use energy. He changed my whole way of thinking and took me from a C+ student to an A+ student. Now I got into trouble in modern physics because they don't observe these two laws, and you can't do anything with relativity and quantum physics because they violate these two laws. Anyway, these are the two laws of science. And everything else comes out of it. Almost all your laws are ideal laws, but we don't live in an ideal world, so you have to put the second law into effect. Now let me give you an example, and I think I told you this before, of making how you can contrast these two laws. Because people are always confusing energy, which is quantity, the first law, with entropy, which is the second law. You take a rock, and a kid throws it out into a very smooth pond. Right before it hits the water, it has energy. You can run a small car for a while with that useful energy. However, it hits, sends out waves, settles to the bottom, and pretty soon the lake is calm again. What happened to the energy? The first law has to be obeyed. You have to have it conserved. Where'd the energy go? The molecules in the lake are vibrating a little more than before. The temperature of the lake is slightly higher. The energy is all in the lake. But pretty soon the lake will give it off to the air, and the air will give it off in the atmosphere to the universe, and it gets spread out over the whole universe. The energy's all there. However, if the second law wasn't true, that lake could use its energy that's in its molecules to pick that rock up off the bottom, form waves again, come together, and throw the rock back at the kid. the first law would not be violated. The second law says you can't do that. You may balance the books. You're the accountant to balance the books, but I'm the manager that tells which way these events go. And they always go from order to disorder. So those are the two laws.